Hi, today we're looking at AQA Functional Skills Maths Level 1. This is the March 2022 paper and we're going to start with the non-calculator section. Question 1. You are facing southwest. You turn 180 degrees. What direction are you facing now? Circle your answer. Okay, well, let's do our compass directions. Always good to think north is pointing up, the opposite of north is south. Then we need to fit the other two directions on. If you remember the little rhyme, never eat shredded wheat. So we've got north, east, south, west. So if you're facing southwest, that means it's going to be halfway between south and west. So you're facing that way. And you turn 180 degrees. Well, that's like half a circle. So you're going to be going all the way around to a straight line, which means you're now facing halfway between north and east, which is going to be northeast. Question 2. Work out 18 plus 30 divided by 6. So with this one, we need to remember our order of operations and we need to do our division before we do the addition. Okay, so this is the bit. So you can think of this almost as if it's in brackets. We have to do this first. Well, 30 divided by 6, let's use our 6 times table. We've got 6, 12, 18, 24, 30. So that's 5 times. So the answer to this is 5. But we don't change the order. We've still got the 18 plus. We haven't done that. But now we can replace the 30 divided by 6 with a 5. So now we can write this as 18 plus 5. We could just count up from 18. So 19, 20, 21, 22, 23, which is what the answer is. Or you could do the 5 plus 8, give the 3, carry the 1, and then 1 plus 1 gives a 2. Either way, we get an answer of 23. Question 3. Measure the size of angle X. Well, if we're going to measure this one, we're going to need to use a protractor, one of these. Okay, and the way that this works is we need to find the crosshairs to the middle of the protractor, and that is going to go right on this point where the two lines meet. Now, we can do it this way. So we need to line up one of these bottom lines with one of these lines here. So this seems the most obvious way. We're putting it inside the angle because this is the angle we want to measure. So if we put that on there and line it up. Now, if we're going to start at this line, because this is a 0, we need to look at these numbers inside. So 0, 10, 20, 30, and we reach all the way around until we find the line that's cutting through it, which is 120 degrees. Now, you might want to start measuring on the other side, but this isn't going to be any good because the angle we want is in here. So measuring this bit is no good to us. However, we can start from this side if we line the protractor up with this line. So we've still got the crosshairs in the middle. We've lined up here. But now, because we're starting at this side, we want the top numbers because the 0 is now at the top. So 0, 10, 20. We go all the way around until we meet the line. And again, we still get the answer of 120. So it doesn't matter if you go from left to right or right to left, so long as you've lined up your protractor with one of the two lines that meet and you're starting from the 0. Question 4. Here are some numbers. We've got 11, 6, 4, 5, 17 and 5. Work out the range. Well, the range is the biggest minus the smallest. Or in other words, it's the difference between the biggest and the smallest. Well, what's the biggest? 11, 17's the biggest number. And what's the smallest? 6, 4. There's nothing smaller than 4. So we basically want 17 minus 4. 7 minus 4 is 3. 1 minus nothing is 1. So we've got a range of 13. Question 5. Work out 40% of 300. Well, I'm going to start off by working out 10% of 300. And I know for 10%, I'm just going to take off a 0. So I'm going to have 30. Well, if I want 40%, well, that's 40 is 4 lots of 10. 10, 20, 30, 40. So we want 4 lots of 30. So we can say 40% of 300 is going to be 4 lots of 30. Well, 4 times 3, 3, 6, 9, 12. And then we just put the 0 on the end. Okay. Question 6. I can line this one up. A day at the seaside. Katja and her family are going to the seaside by train. Katja has a voucher to get discounts on all their return train tickets. And the voucher says, adults 1/3 off usual prices. Children pay £1 each. The usual prices of the return train tickets are adults £24 each and children £11.25 each. Katja will buy tickets for 4 adults and 3 children. How much money will Katja save by using the voucher? Okay, well, let's work out what the full price would be to start with. Then we can work out the reduced price, and then we can work out the difference to find the saving. So if we do full price, so we're going to want adults. We've got 4 adults. So we want 4 lots of 24. So 4 times 4, 4, 8, 12, 16. And 2 times 4 is 8, plus 1 is 9. So 96 is for 4 adults. And the children, we've got 3 children, and it's £11.25 each. So we want 3 lots of £11.25. So we've got this down here. Now what I'm going to ignore the decimal point to start with, and then put it back in afterwards. So 3 times 5, we've got 5, 10, 15. Then we've got 3 times 2, 2, 4, 6. Add the 1 is 7. 3 times 1 is 3. 3 times 1 is 3. Now we had 2 decimal places, so we're going to put the decimal point back in twice. So £33.75 is for 3 children. So if we want the total of those, we want £96 plus £33.75. Well, I want something to add these decimal places to, so I'm going to put a 0.00, just as like a placeholder. But it means now I can say 0 plus 5 is 5, 0 plus 7 is 7. Bring down the decimal point. 6 plus 3 is 9, and 9 plus 3 is 12. So the total full price is £129.75. Now, if we're using the voucher, voucher price, for adults, it said 1/3 off usual prices. Okay, so what we can do is we can work out 1/3 of the normal price, and for the adults the normal price was £96, so we want 1/3 of 96. which is the same. 1/3 of 96 is the same as 96, well 1 times 96, and then divide by 3. So it's 96 divided by 3. So we can do that using the bus stop method. Put the 96 in the bus stop, 3 on the outside. How many times does 3 go into 9? 3, 6, 9. That's 3 times. And how many times does 3 go into 6? 3, 6. That's twice. Okay, so this is telling us this is £30, and that's the discount. So if we want to know the actual cost, we've got to take that off the original price. So we want 96 minus 32, which we can do here. 6 minus 2 is 4, 9 minus 3 is 6. So that is now the price for 4 adults. What about for children? Well, with the voucher, children pay £1 each. So we've got 3 children, we've got £3. So in total, 64 plus 3, 4 plus 3 is 7, 6 plus nothing is 6. So £67, and we're comparing that with £129.75. So how much will she save? So we want £129.75. So this is now the saving. And we want to subtract £67. So if you remember what we did before, we put some zeros in, so we've got something to work with in the calculation. 5 minus 0 is still 5. 7 minus 0 is still 7. 9 minus 7 is 2. 2 minus 6 we can't do. Well, we can take the 1, reduce it to 1 and bring the 1 over. It's the same as just saying 12 minus 6, which gives us 6. So the answer that we want to put down here is £62.75p. So we worked out the total price without any reduction, the price with the reduction, and then we found the difference. (6b). The family go to the beach. Catcher hires 1 deck chair from 11 a.m. to 3:45 p.m. And deck chair hire is £1.40 per hour or part of an hour. Okay. So it's almost suggesting even if you go like 5 minutes into an hour, you still have to pay £1.40. Okay, so it's almost rounding up to the next hour. Catcher pays with a £20 note. How much change should she get? All right, well, let's think. We're starting at 11 a.m. Let's just go up one at a time. If we go to 12 a.m., well, from 11 a.m., it's going to become 12 p.m. because the a.m. to p.m. changes at midday. So that's 1 hour. That's going to cost us £1.40. To go another hour to 1 p.m., it's another £1.40. To go up to 2 p.m, it's another £1.40. To go up to 3 p.m, it's another £1.40. Now we only want to go up to 3:45 p.m. But as we said, it's £1.40 per hour or part of an hour. So even though it's only part of an hour, we still need to pay £1.40. So we want to add these all up, or we can say we've got 1, 2, 3, 4, 5 lots of £1.40. So £1.40 times 5. And again, I'm going to start off by ignoring the decimal point. Just say 5 times 0 is 0. 5 times 4, 4, 8, 12, 16, 20. So 0, carry the 2. And 5 times 1, or 1 times 5 is 5. Add the 2 is 7. We've got 2 decimal places. So 1, 2. So they're going to pay £7. Now she's paying with a £20 note. So we want the £20 minus the 7. And with this one, to be honest, it's probably easy to just start with 20 and count back 7. So 19, 18, 17, 16, 15, 14, 13. So that's our answer. We can put it down here. And 6C. The Beach Cafe sells drinks. We've got the price list there. A hot drink is £2.90 and a cold drink is £1.95. Katja buys 4 hot drinks and 1 cold drink. She estimates, this is the important bit, she estimates that the total cost will be less than £15. By rounding up each price, show that Katja is correct. Okay, so hot drink, if we round up, we can say £2.90. Well, that's approximately equal to £3. And £1.95 is approximately equal to £2. So we want 4 hot drinks at £3. So 4 times 3, 3, 6, 9, 12. It's £12. 1 cold drink, that's just going to be £2. So 12 plus 2, that's just 13, 14. That's going to be £14. She estimates the total cost will be less than £15. Show that she's correct. So we can say 14 is less than 15. And that's the end of the non-calculator section. So now we're on to the calculator section. Question 1. Write these numbers in order of size, starting with the smallest. Okay, well, I always like to write these one above each other. So 67,492, and I'm putting my commas in as I'm going. Then we've got 351, so I'm lining up 968. So I'm lining up my units, my tens, my hundreds, my thousands, my tens of thousands, and my hundreds of thousands. Then we've got 472,410. And if you're not sure about lining them up, start from the units first. We'll write it backwards. So 6, 3, 8, put a comma, 2, 9. Okay, we want the smallest first. Well, we can see these two are the smaller numbers because they haven't got any hundreds of thousands. So if we ignore those two in the middle for now and just say, well, we've got 67,000 and 92,000. Well, 67 is less than 92, so we can start off with 67,492. Then it must be this 92,836. So we've dealt with those two. Now we've got these which are both in the hundreds of thousands. Well, we've got 300 and something or 400 and something. Doesn't matter what the other digits are. 400 and something is always going to be more than 300 and something. So this one comes next. 351,968, and then the 472,410. Let's get this here. This shape, or question 2, this shape is made using 4 cubes. Circle the letter of the plan view. So the plan view is the view like the bird's eye view, looking straight down on top. Well, if you were looking on top of this, all you would see is that square there and that square there. You wouldn't know how tall it is. So we want a picture that's got 2 squares next to each other. Well, it's not that one. It's not that one. Looks like this one. It's definitely not that one. That would be the side view over there. So That's the one we want. And it says circle the letter of the plan view. So it's not the picture we're circling, it's the letter up there. Question 3. Round 17.834 to 2 decimal places. Well, 1, 2, that's our 2 decimal places. So we look at the digit after that, which is a 4. So what we're saying is we know that this number is somewhere between 17.83 and the next one up would be 17.84. So it's somewhere in between the two. It's a 4, so we're getting rid of that one. So we're just going to stick with 17.83. Remember, if this is less than a 5, we stick with what we've got. If it's 5 or more, we need to increase this digit by 1. Question 4. Circle the fraction equal to 0.75. Well, this is the calculator section now, so we can get our calculator and just work them out. 1 divided by 4 is 0.25, so it's not that one. 3 divided by 4 is 0.75, so it is that one. Yeah, hopefully you'll know some of these and you'll be able to spot 0.75 as 3/4. But if not, just use your calculator. And for completeness, let's work out the others. 5 divided by 7. Well, it's not that one. And 7, this is top heavy improper fraction. If that number's bigger than the one below, well, it's going to be more than 1. It's not going to be 0 point something. So that's 7 divided by 5, it's 1.4. So it's definitely not that one. Okay, so use your calculator for these if you can. And question 5. Work out 24 squared plus 37 squared. Okay, well, let's use our calculator for this. So what it's saying is it wants 24 times squared meter times itself. And we're adding on 37 squared, so again, times itself. But we're doing those square bits first, so think of it as if they're in brackets. So 24 times 24 is 576. And 37 times 37 is 1,369. So if we add those two together, we get 1,945. Question 6. Increase 78 by 35%. Well, let's start off by working out 35% of 78. So we want 35 over 100 of means times, so times 78. Oh, 35, I need to slow down. Divided by 100 times 78 gives us 27.3. And we want to increase it by that amount. So we want 78 plus 27.3. Which gives us 105.3. Question 7. Work out the volume of this cuboid. State the answers. State the units of your answer. Well, the volume is the length times the width. Or if we just stop there, that would be the area. To make it the volume, we also need to multiply it by the height. So it's going to be 7.2 times 3.8 times 4.5. And because it's multiplied, it doesn't matter which order we multiply them. 7.2 times 3.8 times 4.5. Got 123.12. And the units, well, it's centimetres, but because it's volume, it's going to be centimetres cubed, because we've got 3 dimensions. let's move this up so we've got a bit more space to work it out. Okay. Question 8, school trips. Mr. Nagger and Miss Burns are geography teachers. They are planning a trip for 34 students to a field centre. Mr. Nagger and Miss Burns will go on the trip. There must be at least one teacher for every 8 students on the trip. How many more teachers are needed? You must show your working. Right, so first of all, we want to work out how many teachers do we need altogether? Well, at least one for every 8. So if there's 34, if we divide that by 8, that'll tell us how many teachers we need. So we need 4.25 teachers. Well, you can't have 0.25 of a teacher. And if we only had 4 teachers, well, 4 teachers, 4 times 8, would only be enough for 32 children. So we need 5 teachers. But we've already got Mr. Nagger and Miss Burns. So we can minus those 2. Well, 5 minus 2 is 3. So we need 3 more teachers. B. Mr. Nagger is working at the time they should leave school for the field centre. He makes these notes. It will take 1.5 hours to get to the field centre. The students will need 20 minutes to unpack. We will then have 45 minutes for lunch. We must be ready for our first activity at 1 p.m. Work out the latest time they can set off. So we almost want to work backwards. But what I'm going to do is I'm going to work out the total amount of time they need and then take that away from 1 p.m. So 1.5 hours, well, we've got minutes here, so we don't really want hours, but I know that 1 hour is 60 minutes and half an hour is half of 60, which is 30. So 60 plus 30, that's 90 minutes. They then need 20 minutes to unpack, 45 minutes for lunch. So how many minutes is that in total? Well, 90 plus the 20 plus 45. Well, that's 155 minutes. Well, because we want to work back from 1 p.m, it's going to be more helpful if we've got this in hours instead, or hours and minutes. So, well, I know that there's 60 minutes in an hour. So if I take off 60, that leaves me with 95 minutes. Okay, so that's 1 hour I've taken off. If I take off another hour, another 60, that takes me down to 35 minutes. And that was another hour I took off. So what we're saying is that this 1 hour or 155 minutes is actually 2 hours 35 minutes. So we're starting from 1 p.m. Okay. Now, if we're going to have to take 2 hours and 35 minutes off 1 p.m, well, 2 is bigger than 1. It looks like it's going to get a bit messy. So I'm actually going to turn this into the 24-hour clock. So if you remember, everything up until midday, we count 12. So 1 o'clock, 2 o'clock, 3 o'clock. When we get to 12 o'clock, we then go to 1 p.m. But if it's the 24-hour clock, 1 p.m. is actually 1,300 hours. So what we want is 1,300 hours minus 2 hours and 35 minutes. Okay. So we can take it away like we do a normal column, but it's a bit different, this one, because it's a time, or it's time, we've got 60 minutes instead of 100. So we don't want 100 minus 35. For this bit, we actually want to say 60 minus 35. And that's going to take us down to 25 minutes. Now, we can do 13 minus 2 to give us 11 o'clock. But we've already gone into an extra hour. By taking 35 minutes off, we've gone into the hour before. So we need to take off another hour from that to make it 10:25. And because it's the morning, it's going to be 10:25 a.m. Okay, so if you want to think of it slightly differently, you can actually, it's nicer to take the hours off first with some of these. So we've got 1300 hours, or even if we were starting at 1 p.m, we still need to take off 2 hours. So take off 1 hour takes us back to 12 p.m. Take off another hour takes us back to 11 p.m. Sorry, 1 hour off of 1 p.m. takes us to 12 p.m. Take off another hour takes us to 11 a.m. Then we need to take off the 35 minutes. So before 11 a.m, that's when we're going to go into our less than 11, which means that the time's going to be starting with 10. But we'd still need to do our 60 minus 35 to get the 25. The total cost of the trip is £3,265. I'm going to put my comma in there. The geography department pays 20% of this cost. The rest of the cost is shared equally by the 34 students. Work out how much each student has to pay. Give your answer to the nearest pound. Okay, well, first thing we want to take off the 20% that's paid by the geography department. So 20 out of 100, because it's 20%. Multiply that by 3,265. Gives us £653. That's paid by the geography department. So that's this amount here. So that means we can subtract that from the 3,265, which means the 34 students need to pay £2,612. So we want to share that equally among the 34 students, which gives us £76.82. Now we don't worry too much about the rounding at this point because they say to the nearest pound. So really the key digit we're looking at is this first digit after the decimal point. It's more than 5, so we need to round that one up to £77 each. Question 9. Garden birds. Simon has a bird feeder in his garden. And I do actually, and it looks not too dissimilar to that one. Let's move up for the rest of the question. On Monday, Simon records the types of birds that visit his bird feeder. He uses the table to work out the angles needed for a pie chart. Okay, so we've got starlings, sparrows, blackbirds and others, and how many we saw. So there was a total of 36 birds, but we haven't got the angles for the pie chart yet. And it says, complete the pie chart. Okay, well we can see starlings are taking up half of the pie chart. Okay, and that is because 18 is half of 36. But what we can think, well, half, what's half of a circle? Half of a circle is 180 degrees. And hopefully what you'll see is actually from 18 to 180, we're just adding a 0. So in other words, we'll multiply it by 10. So we should be able to do exactly the same to all of these numbers. So if we multiply this by 10, add a 0, we're going to get 90. Add the 6 by 10, we're going to get 60. Add the 3 by 10, or 3 times 10, 30. And we can check, because if we add these all up, they should give us the total number of degrees in a circle, which I know you'll all be shouting out is 360. And it does. Okay, so we've got our angles there. Excellent. Now we just need to draw it on the pie chart. Well, we've already got the starlings drawn on. That's fine. Sparrows, 90 degrees. Well, hopefully you know 90 degrees is a right angle. So I could just use my ruler, actually. I'm just going to find the vertical line there and draw it straight across. So I've got my right angle. Okay, so this is going to be my sparrows. Now we want to measure out 60 degrees for blackbirds, and that's going to be in this section here. So I've got my protractor upside down because I need to be measuring this way. What you can, if you find that confusing, you can turn your paper upside down. In fact, let's do that. Okay. So we want 60 degrees. So line up the crosshairs. I'm starting from 0 here. So 10, 20, 30, 40, 50, 60. It's going to be there. So I just do a dot. And then I can connect that. Oh, I missed a little bit. But they will let you be 1 or 2 degrees out. So if it's not spot on, that's okay. So long as you've used a ruler and a protractor. Okay, so this bit will be my blackbirds. So the last section should be others. But we're told that that's 30 degrees. So let's do a quick check. If we measure this one. So I'm measuring it this way now. So I'm starting at the bottom. So I want the 0, the inside numbers. 10, 20, 30. Yeah, that looks good to me. So I've finished my pie chart. (9b). Simon takes a photo of each of the 36 birds that visit the bird feeder on Monday. He decides to choose one of the photos at random. Simon says the probability that the photo is of a sparrow is more than 1/3. Is Simon correct? Okay, well, if you think the sparrows, if we go back to our pie chart, which I've got over here, the sparrows, it was 9 out of 36 birds. So 9 out of 36. Well, we can just put that in our calculator. 9 divided by 36 is 0.25. They're saying the probability is of, I put a 3 there, 0.25. It's more than 1/3. Well, 1/3, 1 divided by 3, is 0.33. Now, comparing decimals, you might be able to see it straight away. But if not, what you can do is actually turn it into a percentage. Okay, so if we go back to the 0.25, multiply it by 100, so that's 25%. And the 0.33, or if we do 1 divided by 3 again, because that keeps going, multiply it by 100, well, that's approximately 33%. But now it makes it easy to compare. So the probability the photos of a sparrow is more than 1/3, or 25% is less than 1/3. So is Simon correct? No. He's incorrect. Okay, so you can just do it comparing the decimals, but I say sometimes it's easier, especially in an exam where you might have, be feeling a bit anxious and want a bit of reassurance. Turn them into percentages, and then it's very clear to see 25 is less than 33%, so that can't be correct. (9c). Simon counts the birds he sees at the feeder each day for the rest of the week. Okay, so Monday, Tuesday, Wednesday, all of the number of birds. In the same week last year, the mean number of birds per day was 39. This year, has the mean increased, decreased, or stayed the same? Tick one box. Well, the mean is the total divided by the frequency, or how many. Well, the total of all of these, we need to add them up. 36 plus 25 plus 30 plus 42 plus 44 plus 26 plus 56 equals 259. And how many have we got? Well, it's 1, 2, 3, 4, 5, 6, 7 days. So 259 divided by 7 gives us 37. It was 39, it's now 37, so that is smaller, so that means it's decreased. (9D). Each day, Simon puts 125 grams of bird seed in the bird feeder. He says a 2.8 kilogram bag of seed will last for more than 3 weeks. Is Simon correct? You must show you're working. Okay. Right. Well, let's work it out. If it's 125 grams each day, and we're looking at 3 weeks. Well, I know there's 7 days in a week, so 3 weeks is going to be 3 times 7. And if you know it, excellent. If not, or you want to check, you can use your calculator. So we've got 21 days. And it's 125 grams per day. So 125 times 21 gives us 2,625 grams. Okay. We've got a 2.8 kilogram bag of seed. Well, I know that there's 1,000 grams in 1 kilogram. So if we want to turn this from kilograms into grams so we can compare, we want to multiply 2.8 by 1,000, which gives us 2,800 grams. Okay, well, he needs 2,625 grams. That is less than 2,800 grams. So this is what he needs. This is what he's got. Well, if he needs less than what he's got, well then that's going to be fine. So is he correct? Yes, he is. Question 10. Liam is a photographer. Liam is asked to take photos at Molly's party. He uses this formula to work out his fee. The fee is £40 plus the number of photos times £3.75. Molly wants 18 photos. She gives Liam 6 £20 notes. How much change should she get? Okay, so a couple of things. We need to work out what the fee is. We need to work out how much money she gives him. And then we need to work out the difference. I'm actually going to do this bit first because this feels nice and simple. If she gives him 6 £20 notes, we want 6 times 20. I won't use a calculator because I know that 6 times 2 or 2 times 6 is 12. Add the 0. £120. So that's how much she gives him. Now we work out the fee. So we've got £40 plus the number of photos. She wants 18 photos. And that's £3.75 each. Okay. Now, and I had a couple of comments on this recently, a very similar question. The number of photos is times £3.75. So this £40 is fixed. If you remember from order of operations, we do the multiplication first. So we need to work this out before we add on the 40. Okay, so we can say that this is the same well, keep the 40 because we haven't done anything to that yet. But we now want 18 times £3.75, which is 67.5. Add on the 40. And now because it's money, I'm not going to say 107.5. It's going to be £107.50. We need 2 decimal places when it's money. So she gives him £120. It only costs £107.50. So if we take that away, we're left with £12.5 or £12.50. (10B). Liam also takes school photos. He sells the photos in 4 different pack sizes: A, B, C and D. Liam kept a tally of the packs he sold one day. And we've got the tally chart here, but they've not filled in the frequency. Liam says, I sold more than 4 times as many of pack A as I did of pack C. Is he correct? You must show your working. Well, I'm going to work out the numbers first. So we got the tally, but let's turn it into actual numbers. Now, each of these, if you know how the tally chart works, each of these groups is like 1, 2, 3, 4, 5. So when you see a group of this, that's 5. And that's another 5. And another 5. And another 5. So in other words, we've got 5, 10, 15, 20, 21, 22. So we've got 5, 6, 7, 8, 9. 5 and 1 is 6. 5, 10, 11, 12, 13, 14. Okay. Right, so we've got our numbers. Liam says, I sold more than 4 times as many of pack A as I did of pack C. Pack A, as I did of pack C. These questions sometimes can be worded in a really horrible, messy way. What they're trying to say is that they think that the answer to A is more than 4 times the answer of C. So if we do 6 times 4, we get 24. Well, that's not more than 22. It's less than 22. So is he correct? No, he's not. If you find it difficult interpreting the language, because it can be messy, then think, well, we've got 4 times, and we're talking about A, and we're talking about C. So if we look at these 2 numbers, we can kind of think, well, what could I do with those numbers? So sometimes you might almost need to work out the question a bit yourself if you're not sure exactly what they're asking for. Okay, ideally, you want to interpret what they're saying, but they can write things in such an awkward way that it can make it difficult. And you don't want it to throw you, so look at it and just think, well, what could they be asking me? Okay. 10C. Liam wants to arrange 6 photos on a display board in his studio. The board is a rectangle with width 120 centimetres and height 140 centimetres. He has 1 photo of width 60 centimetres and height 60 centimetres. Actually, I'm going to draw a little sketch of that. So he's got 1 of these, which is 60 by 60. That's that one. 2 photos of width 30 and height 40. So 30 centimetres and height 40 centimetres. That's those. And 3 photos of width 25 centimetres and height 15. So width 25 and height 15. Okay, these are just quick sketches. So they're not to scale. Obviously, that's not bigger than that. Doesn't matter. Just for sketches to help me to start to visualise this. There must be a space of at least 10 centimetres between photos. The grid is a scale drawing of the display board. So this is the grid they're talking about down here. Okay. And it's asked us to use the grid to show how Liam could arrange the photos. And we're told that one square, so one of these, represents a 10 centimetre by 10 centimetres square. So that's like saying, actually I'll do it on here. That's 10 centimetres and that's 10 centimetres. Okay. So let's think about our first photo. Well, if this is 60 centimetres, well, how many squares is it going to be on here? Well, what we need to do is 60 divided by 10 means it's going to be 6 squares across. And it's also going to be 6 squares up because it's the same both ways. If we think about this picture over here, well, it's 30 centimetres across. Well, 30 divided by 10 means it's going to be 3 squares across. And how many up? Well, we do something similar. We do 40 divided by 10, which is 4 squares up. And you might see a bit of a pattern, although with this one, slightly different. I mean, still the same approach, but if we do 25 divided by 10, we're going to get a decimal. So it's going to be 2.5 squares across, and 15 divided by 10, I nearly gave the answer, is going to be 1.5 squares. So when we're trying to do these planning questions, it's always good to start with the biggest one first. So we've got one photo that's 6 squares by 6 squares. So let's get it out of the way. Let's get it over in this corner. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay, so this is going to be our... This is one photo, okay? 60 by 60. So we can put it... Right, now let's go for the next biggest ones, which are 30 centimetres width and 40 high. But also remember, there must be a space of at least 10 centimetres between photos. Well, if each of these squares is 10 centimetres, I'll bring it down so we can see, then that means we need 1 square between each photo. So what I'm going to do is draw a sort of a border around this photo and scribble it out because we can't have anything in there. Okay. But we do want a photo of width 30 and height 40. So maybe we can do it here. 1, 2, 3 wide and 1, 2, 3, 4. Okay, so we can have, this can be our 30 centimetres by 40 centimetres. Okay. And again, I'm going to draw my border around it, so we make sure we don't put anything in there. Now we need another one of these. I want to make sure I can fit everything in, so I'm thinking maybe let's put it over out of the way. So we want the width of 30, so let's go 1, 2, 3. So this is going to be 2 corners of it, and a height of 4 squares, so 1, 2, 3, 4. So this is another 30 centimetre by 40 centimetre picture, and we want our 1 square border, which is the gap there that we've got to have. So I can tick these off. We've done the 1 photo, we've done the 2 photos. Now we need 3 photos, which are 2.5 squares wide and 1.5 squares high. Well, I don't know how much space I'm going to have, so let's start right down in the bottom corner. So 1, 2.5 wide, 1.5 high. Okay, so that's 2.5 centimetres by 1.5 centimetres. And we need 3 of these. So if I want to draw my 1 centimetre square around it, I'm going to go from half a square to half a square. So it's going to be something like that. So we can't have anything in there. So I'm going to draw another one right next to it. So we've already got half a square, so half, and then we get our 1, 2. And the height is going to be the same height that that one was. So that's a 2.5 centimetre by 1.5 centimetre. We need our 1 centimetre border around it again. So 1 square that way. Sorry, 1 square, not 1 centimetre. Okay, so we can't have anything in that space. And then we want another 1, 2.5, and going up 1.5. Right. So we've now done the 3 photos as well. Okay. It might not be the prettiest layout. You might think they look a little bit sort of jumbled up together, but that's fine. So long as we've met the criteria, we put on all the pictures that we needed to. These ones down here. We've made sure we've got our 1 square gap all the way around them. In fact, if we do the gap around this one as well, just to make it clear we haven't gone anywhere we shouldn't have done. And it's done. So it can be quite time consuming, these, and there could be loads of different answers. Obviously I could have put this down in the middle and the pictures around it, but go with what's easiest. Try to get the biggest ones out of the way first, and then you can fit the smaller ones in around it. Okay. Question 11. Patchwork. Daisy is making a cushion. The front of the cushion has a patchwork design made up of 16 square patches. The back of the cushion is a single piece of fabric. 11a. Daisy starts to make a sketch of her design. 6 of the squares will be grey. The rest of the squares will be white. She has shaded 3 of the 6 grey squares. Shade 3 more squares so that the design has at least 1 line of symmetry. Okay, so that's what we've got. So we want to draw, we've got our 1, 2, 3 grey squares. We want to draw 3 more. We want to have a line of symmetry. It's up to you where you put the line of symmetry. I think that the simplest way for me is if I've got a line of symmetry down the middle. So I'm just going to lightly draw that on. So imagine I had a mirror there. Where would these 3 be reflected in that line? Well, this one would be right next to it there. This one, well, it's got a gap, so we'd have another white one up directly next to it, but the grey one is going to be over here. And this one's up here. So again, we've got a blank one next to it, and the grey one will be over there. So there could be more than one answer to this, but I think that's probably the simplest way to do it. (11b). Each of Daisy's square patches measures 14 centimetres by 14 centimetres. There is a 1 centimetre border around the patchwork, so these are 14 by 14. This is 1 centimetre. And the diagram shows the front of Daisy's cushion. Okay, so there's 16 squares, border around the outside. The front and back of the cushion are the same size. Daisy has a square piece of fabric with an area of 3,600 centimetres squared. She wants to cut the back of her cushion from this piece of fabric. Is this piece of fabric big enough? You must show your working. So what we need to do is work out what the area of this is. Okay. So we can start off, well, if we want to work out the area, we want the length by the width. Now, because it's a square, they're going to be the same. So it's going to be the length times the length. So in other words, if we can just work out this distance then we can work out the area. Well, if that's 14, that's going to be 14. Do the little arrows on. That's going to be another 14. And that's going to be another 14. Now remember, we've got one up at the top and one down at the bottom. So we want 1 plus 14 plus another 14 plus another 14 plus another 14 plus 1 at the bottom. Okay, you could multiply the 14 by 4, but I'm just going to keep it simple. So 1 plus 14 plus 14 plus 14 plus 14 plus 1 gives me 58 centimetres. Okay, so the area is going to be 58 times 58, which gives me 3,364 centimetres, and because its area is going to be centimetres squared. Well, 3,364 is less than 3,600, so is it big enough? Yes. It's big enough. (11C), the last part of this paper. Daisy also sews a patchwork quilt. The quilt is a rectangle. So we've got 145 centimetres long and 120 centimetres wide. Daisy wants to put cord around the outside edges of the quilt. So going all the way around here. She has 3.6 metres of cord. How much cord does Daisy need? So this is a perimeter question, because we want to know the distance around the shape. Okay, well, I'm going to write it in. We haven't got the distance here, but it's going to be the same as that. And this side's going to be the same as over there. So the perimeter is going to be 145 plus 120 plus 145, and finally plus another 120. So 145 plus 120 plus 145 plus 120, that gives 530 centimetres. Now they've given us the amount of cord they've got in metres. So we can either convert the metres into centimetres, or we can convert the centimetres into metres. And it really doesn't matter, so long as you remember the conversion, that there's 100 centimetres in 1 metre. Normally I'd say convert it into centimetres, the bigger number, so you avoid decimals. But this time I'm going to divide it by 100. I'm going to turn the centimetres into metres. And we know we need to divide it because metres are bigger than centimetres, so we're going to have fewer of them. So we're making the number smaller. So 530 divided by 100 equals 5.3 metres. So she needs 5.3 metres. She's got 3.6. So if we subtract how much she's got, this is going to give us the extra that she needs to buy. So 5.3 minus 3.6 equals 1.7 metres. Let's say if you wanted, you could have multiplied this by 100 to make 360 centimetres and then work out the answer in centimetres. Because they haven't, if you look at the answer, they haven't said what units to use. Okay, so that's fine. If they'd given centimetres down here, then I would have worked it out the other way instead. But that's the end of the paper. Hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on so you find out when I upload more videos, and I look forward to seeing you all again soon. Thank you.